Now, there is a way to do this number 25 that involves more like SAT strategy. So we have equations. That's a sign that maybe that plug points into equation strategy could work. And the way that they're asking the question, they're asking for the x coordinate of the point of intersection. So we're given 4 x coordinates as the choices. So we can kind of guess and check these choices and see if they fit, and then we'd have to solve for y. So it's definitely possible. However, I don't think it's the most efficient, and I actually think that most people's instinct on a question like this is just going to be to do the algebra. So for that reason, I'm going to kind of do it that way too, and hopefully along the way, I can just reinforce some good habits that you'll need for a question like this. So the most important thing for these kind of point of intersection questions is that there's going to be a lot of steps. And it's very easy to lose track of a negative and get the wrong answer, and you should know that the answers that are wrong are not random numbers. They're the numbers that you would get if you make the careless mistake. So we have to be extra cautious, because if we do make the careless mistake, we might not know. We might not be able to catch it. So we've got to be careful along the way. So our strategy here is let's just show your work. So for most point of intersection questions on the SAT, if we have 2 lines, which we have here because there's no exponents on either of the variables, our go-to way to solve is going to be what's known as the elimination method. And this is basically where we want to try to change one of the equations so that the variables cancel when we add them together. So we're looking for something easy to multiply by here because the x's and y's are too different. But I do see that with the y's, one is negative and one is positive. So that's kind of like a clue to go in that direction. So what I want is the number, the coefficient attached to the y, to be the same, one positive, one negative, so that they cancel each other out. So what I'm going to do is take the second equation and multiply it by 3, because it's going to make the 0.5 into 1.5. Okay, so let's be thorough here. Let's rewrite the first equation. Okay, 2.4x minus 1.5y equals 0.3. Right? Just get it out, same as it was on the top, no change. But the second one, we've got to make sure that we distribute that 3, I'm going to do it underneath here, to all the parts. So if you notice that when you're taking SATs that sometimes you forget to distribute, draw those little arcs like I just did, right? Give yourself a visual reminder that that 3 needs to go to all those parts. You're less likely to forget, and that means you're more likely to get it right. So we also have a calculator. Let's not hesitate to use it here. So 3 times 1.6 is 4.8x. And we don't need to do this because we picked the number 3 on purpose, but 3 times 0.5 is plus 1.5y. So there's now the same number on the y's. And then negative 1.3 times 3 is going to be negative 3.9. Okay, so step 1 of elimination is we got to get something to line up in a convenient way. Step 2 is now we just add these equations as if they were numbers. So that means we have to combine like terms basically. So the 2 x's are going to add together. 2.4x plus 4.8x is 7.2x. But when we do the same thing to the y's, because one is negative 1.5y and the other is positive 1.5y, those two things are going to cancel out, right? Negative 1.5 plus 1.5 is 0. So the reason we do this and the reason we call it elimination is we're eliminating one of the variables. Because when we have 2 variables, we can't really solve the equation and figure out what they mean, what their numbers are. But when we have 1 variable in 1 equation, we can solve. So let's finish the job here though. So 0.3 plus, or minus here, plus negative 3.9 would be the same as minus 3.9. And that is going to be negative 3.6. So now this orange represents the 1 equation that I'm left with after I've eliminated the y's. And now I can just do some kind of regular algebra here to solve for x. So I would just get x by itself by dividing by 7.2. So x is equal to negative 3.6 divided by 7.2, and x is negative 0.5, which is choice A, and that is the answer. So sometimes we're going to still need to do more, right? If they had asked for y instead, I would need to go back into the question and find the value of y by substituting that x in. So there might be an extra step, and so you always want to be careful, like what are they asking for? Like it's a good habit to show your work and underline the thing that they want so you don't accidentally give them the wrong thing, because sometimes that happens. You solve for x, that's an answer choice, but they actually wanted you to solve for y. And so it's so tempting to just pick that answer choice as soon as you see it, but we always want to make sure we're giving the SAT the exact thing that it's asking for. So again, just kind of like with the distribution thing, pay attention to the kinds of mistakes that you make. If you make that mistake of giving them the wrong variable, get in the habit of underlining the question so that you don't forget. They want X, not Y. All these little things add up over the course of an SAT, and that's real points that you can save just by changing your process, showing your work a little bit more clearly, so that if you miss something, you're more likely to catch it in the moment.